Hey everyone, welcome to your play pause it for the day. We are going to be going over lesson 4.5 in your OMHS. And this is a unit or lesson that I did need to have to add in as the OMHS did not have material covering it. So that's why you see, unit 4 material and then unit 5, and then there's like a squeezed in, there's a squeezed in 4.5 there. So it's direct and inverse variation. It's really small, really short, just sort of two different topics for each of those that we're going to need to cover for this year. So go ahead and grab your notes, have your play pause it graded assignment, and let's get going. Before we get too far, just a reminder that you guys can pause this recording at any time, whether you're watching the play pause it or you're watching the view peer link. So you can pause it to take your notes or to try the questions on your own. Don't forget that our very exciting extra credit opportunity is due by Monday today, by midnight, essentially. You guys know I don't want you making gingerbread houses at night, but you do have the rest of the day to get that turned in. And there's a project sheet for the extra credit in your OMHS under extra credit. So you actually don't have to build anything. You can definitely draw it. You can make it out of pipe cleaners or popsicle sticks, anything that you want, as long as you can fill out that project sheet. And another reminder in the same vein there is that we have our Wonderland of Gingerbread coming up, and we would love to share your designs with the school. So if you would like to do that, then you're going to want to submit those via this Google form, and I'll put the link in the play pause it. And if for some reason you're not watching the play pause it and you're watching the view peer link and you would like to submit this, then you can find this on our course page as well, or you can always just send me an email. All right, so let's get started. The first thing I wanted us to look at is, what do you think? So we have three different things here, and I'm wondering, what do you think these three have in common? And I know that we're not together in person, so we can't really talk back and forth like we might normally in a class, but just think, I want you to think about it in your mind. What might these things have in common? And I don't know about you, but when I compare things, I like them to be as similar as possible, so I can clearly see what they have in common and what they might share that are different. So this is a graph, right? And we have a table, and then we have a function. Well, we can write this in function notation with f of x as well. So basically just the equation. So these are the three different ways that we can represent a function. And if I wanted to compare them, I might look at them all the same way, like maybe all graphically. Let's see what they look like graphically. So here's the first one as a graph. The second one, we can plot these points, just kind of eyeball it, right? 0.5, 10, 1, up 20, 2 up 40, 0, it would be 0, 0 there. It's kind of a weird. Boop, doop, doop, doop. If I kept going, it would be 0, 0, because I know the function rule. All right, let's look at this second one here, y equals 3x. So if we were to graph y equals 3x, the y-intercept is 0, right? There's no value here, so it's going to go through 0, 0. And the slope is 3 over 1, so up 3 over 1. Approximately like that. So what do all of these three have in common? It looks like they're all positive slopes. That kind of happens to be just a coincidence, but they are all going through the origin. They're going through the origin. They also have some kind of constant slope, right? The slope of this one is 3. This one's going up and over, it looks like up 1 over 10. 1 over 10. This one is up 4. 1, 2, 3. Nope. 1, 2, 3 over 1. 1, 2, 3 over 1. Up 3 over 1. Excuse me. So all of these do go through the origin. So these are all very special. These are examples of what we call direct variation. Direct variation. Y varies directly with x. So all direct variation graphs are going to go through the origin. If you see a graph like this, guess what? That's not direct variation. If you see a graph like this, that is not direct variation. See a graph like this? So direct variation graphs go through the origin. So let's talk a little bit more about direct variation. There is a general form of this, and we can show you using function notation. It's f of x equals k times x. So k here is called the constant of variation. Now, in your minds, you guys usually think this would be m, the slope, right? And it is, essentially. The value in front of the x is the slope, and that's the change in that line. That's the variation or change in that line. And the number is constant, right? Once you have it for the function, it's not going to change. Like, for example, this one, the constant of variation was 3. Just is 3. So K is called the constant of variation. And this is the direct variation in function notation, but we can also see it written using Y a lot. So I wanted to show you both ways. I typically tend to work with it using the Y. I'm not sure, I'm gonna sneeze, hold on. Okay. I'm not sure why, maybe growing up, this is how I learned it, but you can use it either way, f of x or y. I guess I'm gonna stick with y because again, that's how I learned it. And I think that's how it shows you in your OMHS as well. So this K value is pretty helpful and super important. And so if we can have an equation that helps us solve for that, that's going to be helpful because K is that slope value. So sometimes you'll see people, mathematicians, solve this for K. They'll say, okay, well, what does K equal? So how would we get K by itself? To think, well, this is times x. What's the inverse operation or the opposite of multiplication? And that's division. So we'll divide both sides by x. And this is us just rearranging the equation. That's all. We've done this before under solving literal equations. So we just rearranged it to get k by itself. Again, this is going to be a really helpful tool for us when we're trying to determine whether a function is direct or inverse. So for direct variation, you actually take the y value and you divide it by the x value, and you'll find k. So for every single y value, when you divide it by x, you'll get k. Let's look at this one again. So this is p and q, but you guys know it's the same as x and y. So let's try it. Let's have a column for y divided by x. So 10 divided by 0.5. 10 divided by 0.5, and that's kind of funky. We don't usually see that. And you can certainly use your calculator. When you plug that into your calculator, you actually get 20. So let's go back here, because if you think about it, that's really 10 divided by 1/2. And we haven't done this yet by hand, and we will, but when you divide by fractions, you multiply by the reciprocal. So that's really 20. For the meantime, you can use your calculator. We get 20. 20 divided by 1, y divided by x, that is 20. And 40 divided by 2, that is 20. So see, look, it's constant. It's not changing. It's always 20. So the constant of variation for this one is 20. And this is a way for us to prove that the function is direct variation. So if you can do this with a table, you've shown, sure enough, this is direct variation. If you take y divided by x, you'll get the same number every time. If for some reason you get something else here, then it's not direct variation. It's something else. So the super important things here is knowing that the general form for direct variation is y equals k times x. That's like the function notation that you're used to seeing. And then k itself is y divided by x. You don't really have to memorize how to find k, right? Because as long as you know this one, you're good, because you can always take this one and solve it for k, like we did. So knowing that direct variation is k times x, you'll be good. So when you see direct, you think y equals k times x. And then we can always solve for k if we need to. All right, so let's try some. So I'm going to put this up here so we remember it. This is the general form. And then k, that constant of variation, is y divided by x. So a way to check these, again, is to have a column here where you're taking the y, you're dividing it by the x, and see what is that k value? What is that constant of variation? So 10 divided by 2, that's 5. 20 divided by 4, ooh, that's 5. We're on to something. So far, so good. And 30 divided by 6, sure enough, that is 5. So this checks out. This is direct variation, and the k value is 5. Perfect. Let me get a different color, because why not, right? Let's try this one. We're going to take the y value and divide it by the x. So 10 divided by 5, that's 2. 20 divided by 10, that is also 2. And 30 divided by 15 is 2. Yay! It is direct variation. We've proved it, and the k value is 2. So if you have the k value, you guys can write an equation, right? It's y equals 2x. We just plugged it in for k. This one would be y equals 5x. Done. And both of those go through the origin. Remember, there's the y-intercept for direct variation. It's always 0. See, there's no plus anything, so it's 0. There's no b value. All right, let's try this one. I want a new color. Okay, we're going to take y, we're going to divide it by x. 1 divided by 1, that's 1. 4 divided by 2, oh, that's 2. These are already different. And we can try the second one or the third one if you want to, but these are all different, so it's not constant. So you can see that this is not direct variation. No, no, no. Excuse me. All right, so we proved it's not. So let's look at the last one here. Y divided by x. 5 divided by 1 is 5. 10 divided by 2 is 5. And 15 divided by 3 is 5. This is direct. And the k value is 5. See, it's constant. It's the same. 5, 5, 5. That's the constant of variation. And our equation is y equals 5x. Beautiful. So again, let's take a look at some graphs. I know we saw one earlier. But if you look at these 4 graphs, which ones are direct and which ones are not? So you can very clearly see immediately. Remember, direct variation must go through the origin, right through 0, 0. It must, or else it's not direct variation, something else. So the first one here, yep, goes through the origin, that is direct variation. Goes through the origin, that is direct variation. This one does not. This one does go through the origin, but it's not linear. So we're going to add that to our must. It must be linear. It must be a line. This is a curved, this is a cubic, so this is not direct variation. So we can very visually quickly see if it goes to the origin and it's a straight line, then it's direct variation. So let's look at the other type. And if you were paying attention on the very, very first slide, you know that this is going to be inverse variation. And if you have your notes, you see the same thing. This is the other type of variation you're going to learn this year, the only other type. So these are examples of inverse variation. And you can see they're way different than direct, right? We have some curved lines here. This is an example of exponential decay, where it's going down exponentially. You'll also see these in pre-calculus, and they're hyperbolas. So this is only part of it, and then the other part would be in the other quadrant. and it's an example of a hyperbola. Hyperbola is a conic section. And if you decide and you get into the honors module, we're going to do some cool stuff with conic sections. So these are some examples. We're not going to be specifically graphing these this year unless you take the honors module. We're just going to be sort of examining them in regards to inverse variation. So now you know what they look like. If we were to graph y equals 3 over x, let's go to Desmos to do that. I'm sure you could do it by hand by making a table, but like I said, it's not part of our curriculum this year, and we can always use Desmos to help us. So there it is, just kind of like what I sketched earlier. This is y equals 3 over x. So you can see it's not a line, it's not a straight line, and it's not going through the origin. And this is exactly what inverse variation looks like, these exponential decreases and exponential increases. So over here, I really just wanted to point out the curvature. Typically, you're going to see the graph in the first quadrant, so you're only going to see that part in our class. But if for some reason you move on to pre-cal, you'll see it this way with the two pieces. And next class, you guys, we're going to look at some real-world applications of this stuff. So I know that right now it's very mathy. And you're like, what even is this? So we're kind of just following some steps and some rules. Identify the two different types of variations. So just hang in there with me. So let's take some notes for inverse variation. Much like direct variation, this has a general form. Our function notation is f of x equals k over x. That is the inverse variation. You remember the example, how it had 3 over x? So you're dividing by x on the bottom in the denominator. And again, you'll usually see it written with the y in this unit. So it can be helpful, again, to solve for k, because k is that constant of variation. And it's what helps us determine which type of variation exists, like we did in all those little tables. So let's do that. I'll just remind us that k is the constant of variation. It's essentially the slope. I mean, you could think of this written as k times 1 over x, right? It's the same thing. We kind of pull that k to the front like as the coefficient. So that k is the m value, the slope value, essentially. It's a little more challenging to see in this type of graph, in the curved graph, but it essentially means the same thing. It's how the graph is varying. Okay, so let's solve for k. So if we have the general form, how could we get k by itself? We got to get rid of the x. So this is divided by x. What's the inverse of divided by? It's multiply. So these will divide out, and you're left with k equals x times y. So I don't know if you've noticed yet, if you've been taking really good notes, you'll see that they're kind of opposites of each other. Remember, direct variation, we were multiplying, and then the k value was dividing. Inverse variation, we're dividing, and the k value is multiplying. And that's not by coincidence, like that's by design. They're essentially inverses of each other. So it's pretty cool. All right, so to find that k value, all you do is you multiply x times y. And if it's the same thing, then sure enough, you have an example of inverse variation. So let's try it. I'm going to remind us that inverse is k over x, and k equals x times y. So again, you don't necessarily have to memorize both of these. If you just remember this one, and you can always solve for k and get it by itself. But I will say it's much easier and more helpful to know what k is by itself, because we're going to use that here. We're going to say, okay, well, what is x times y? So 1 times 12, that's 12. 2 times 6 is 12. 3 times 4, it is 12. It is a constant value. It's staying the same, 12, 12, 12. So our k value is 12. And again, we could write the equation for this. It would be 12 over x. You just plug that k value in to the general equation. Let's try it again. Don't forget, you can always pause and try it on your own if for some reason I didn't pause you on purpose with the play pause it. All right, these are getting kind of big. Let me do 2 times 12. I know that's 24. And I know 1 times 6 is 6. Let's do 3 times 18. That's 4. Is that 54? I mean, obviously you can see that these are not the same. Not equal to. So this is not inverse variation. What is it? Whoa, whoa, pen, whoa. Now this one just wanted you to check inverse variation, but if you look at it, you could always say, well, wait a minute, is it direct variation? Let's see. Remember, the rule for direct variation is taking y over x. So 18 over 3, that's 6. 12 over 2, that's 6. 6 over 1, that is 6. So this actually happens to be an example of direct variation. So we kind of have these two tests. We have the x times y and the y divided by x. And whichever one the table passes, that's the type of variation it is. And that'll help us get the general form. So here, 6 is the k value. So for direct, remember, it would be y equals 6 times x. And you could graph that, and we would see that all of these points line up with that line. All right, let's do the bottom one. We're going to check for inverse. So 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is 9. So this is definitely not inverse because this value is, sorry, this value is not constant. It's changing. So we could check direct. Y over x. 1 divided by 1 is 1. 2 divided by 2 is 2. Here's another direct variation. And you know, guys, a lot of times with these, you'll be able to sort of look at the graph and tell because you'll start to see patterns. Once you do these enough, you'll start to see patterns and you'll be like, wait a minute, that's definitely not inverse. Let me just double check direct. And it is. And hold on, I messed up here. This should be 1, right? 3 divided by 3 is 1. So the constant of variation is 1. So k is 1, which means our function is y equals 1 times x. All right, let's try the last one. This is kind of fun, I think. X times y. So we have 1/6 times 12. What is that? Now you can definitely, again, do this in your calculator, or we can just do it by hand. 1 over 6 times 12. Remember, with multiplying fractions, just do the top times the top and the bottom times the bottom. So we're going to have 12 over 6, which is 2. How about 1/4 times 8? 8 over 4, which is 2. And 1/2 times 4? 4 over 2, which is 2. Yay, these are all the same. They are constant. So the inverse test checks out. This is inverse. Whoops. So the equation is going to be, the general form is k over x, so 2 over x. All right, I'm not sure why those carried over. I bet you it's going to carry over through the whole presentation. I'm sorry about that. I need to look at how to fix that with PowerPoint. So this is just another example, a graph for you guys of what inverse looks like. It's these curved lines. They look just like this all the time. And here's an example of the general form and then our k value. And you can see the k value is 16 from the general form. That's just another example there for you. So let's do some of these. Sometimes you'll see the charts written horizontally. So now we have the x's going across the top and the y's going across the bottom. So all we have to do is do the same test, right? So inverse variation, we're going to test to see it's y times x, right? And if we get the same value every time, we know it's inverse. So let's try. I don't know why I picked inverse first. You could pick direct as well. We need to decide which one it is. So 1 times 5, that's 5. 0 times 0, that's 0. So already they're different. So we know it's not inverse. We know. So let's make sure, let's check and see if it's direct. Because if it's not direct, then it's neither. So let's test direct. Remember, with direct variation, we're going to test y divided by x. So we're going to have -1. How can we do this? Divided by, or I'm sorry, y divided by x would be -5 divided by 1. So that's a +5. Before we go much further with testing for direct, I want to finish out the inverse because we're going to see something here. 1 times 5 is 5. And 2 times 10 is 20. Okay. So there are two cases here where they're not the same. They're not 5. So we know it's not inverse. So let's continue with direct. So we're dividing now. 0 divided by 0. That is undefined. And if you don't believe me, you can never divide by 0. It is undefined. And that's because you can't have 0 groups of 0. So that's undefined. 5 divided by 1 is 5. 10 divided by 2 is 5. So everything else matches except for this special case here at 0, 0. If you remember, direct variation does always go through the origin. So it does always have a point at 0, 0. Always. Whether it's that way or this way, that is going to be a point of the function. So let's just say that we're going to say this is direct and 5 is the constant of variation. That means our general form is y equals 5 times x. So does the point 0, 0 work? If I were to plug in the point 0, 0, 0 goes in for x and 0 goes in for y. Sure enough, 0 does equal 0. It does work. The only thing here that's the problem, I guess, or the special case with our direct inverse testing, if you will, is that you can't divide by 0. So anytime you're trying to do a direct variation test and you have a coordinate point that's 0, you'll always get undefined. But we need to go beyond the test, right, and tap into our brain and our thinking and say, wait a minute, the coordinate point 0, 0, that's right at the origin. I know direct variation graphs go through the origin. So it is a point on the line. So sure enough, this is direct variation, y equals 5x. All right, let's test this one. Man, I really wish that red line and yellow line could go away. I need to look in how to do that. I tried to erase it. I tried to select it and delete it. Yeah, nothing's working. If anybody knows, let me know. I think what happened was I did like an auto draw from my stylus, and now I can't get rid of them. So I do apologize for that. But let's do the test. Let's do direct first, just because it's coming first in the sentence this time. I know last time I chose inverse. So the direct test is y over x. So if we take each of these y values and divide it by x, and we get the same thing, we know it's inverse. So 2 divided by 1 is 2. 1 divided by 2 is 1/2. We can keep going. 2/3, careful here, 2/3 divided by 3. So this is really 2 over 3 times, you're going to divide by the reciprocal, 1 over 3. You're going to get 2 over 9. 3. So let me show you in the calculator. 2/3 divided by 3. 2/3 divided by, see, no, that didn't even do it right. Let's do parentheses. 2/3 no divided by 3. There we go. is 2/9. Exactly what we have here. So I'm sure you guys can already see it's not direct variation, right? Because these are all different. 2, 1/2, 2/9. So usually when it's not direct, it's inverse, but let's just make sure. So this would be 1/2 times, you flip it. Again, we have not reviewed how to do this yet, so I would just use your calculator. But we will be to get these fractional answers. So this is not direct. It's definitely not direct. Let's test inverse. So let's do it here amongst the red line. So remember, inverse is y times x when we do the test. So 1 times 2 is 2. 2 times 1 is 2. 3 times 2/3. Aha. Remember, we could put this over 1. These are going to cancel or divide out. So it is 2. 4 times 1/2. Put this over 1. You get 4 times 1 and 1 times 2. And this is 2. They're all 2. So it is inverse. And k is 2. So remember, the general form for inverse is y equals k over x. So it's going to be y equals 2 over x. If for some reason you're getting hung up on this fractional computation here, I would like to say, like, don't stress. Use the calculator and then come to me for help if you want to do this multiplication by hand. We can certainly find some review on Khan Academy or IXL. We're going to be reviewing the division and stuff, which will in turn, review the multiplication. But, excuse me, try not to get too hung up on that for this particular unit. So here's some more examples. This time, there's no table. See? No table. So this time, they want you to actually find the equation, just giving some information. So it tells you y varies directly with x. So when you see this sentence, you should automatically think y equals k times x. That's the direct variation general equation. Y varies directly, that's going to be the multiplication, with x. So that's the first thing we want to write. Then it tells you if y is -4 when x is 2. So let's try that. If y is -4, I'm going to plug in -4. I don't know k, but I do know x is 2. So I plugged that in. So let's solve for k. We're going to divide both sides by 2. And we get k equals -2. Now we have that very special k value. We can finish this up because it says find y when x is -6. So we're going to use this k and plug it into the general form to get our general equation. There it is. There's our general equation with our slope, with our k value. Remember, you can use this to find any point on the graph. They just wanted you to happen to find the one when x is -6. So, you could, if you had a table with x and y, they're saying x is -6, what's y? So now that we have this general form here with the actual k value in it, the slope in it, all we have to do is plug in x is -6. So y equals -2 times -6. Y is 12. And you're done. You gave them the answer. Find y. You found it. So this just has one extra step where you have to use this given information, plug it into the general form to solve for k. Let's try it again. This time it tells us y varies inversely with x. So you see that sentence and your brain should automatically, maybe not yet, but it will automatically write the general form of the inverse variation is y equals k over x. So let's use the given information, y is 40 and x is 16, and plug it in. Oops. So y is 40 and x is 16. And solve for k. So remember, this is divided by 16, so we're going to multiply both sides by 16. to get rid of that. We get k equals, this is a big number. I just plugged it in my calculator and I got 640. K is huge. So now look, you can use the k value and find a general form. Plug it into our general form. So it's y equals k of 640 over x. Now we have the rule. We have the function rule that we can use for any x and y value. They happen to want us to find x when y is -5. Okay, so let's plug in. You can also do this in the calculator. Let's plug in -5 for y and find x. This one is a little bit different since x is on the bottom. We can set this up over 1 and we can cross multiply. That would totally work. So 1 times 640 is 640, and x times -5 is -5x. Now we just divide by -5. So x equals 640 divided by -5. Let's see. -128. X is -128. And you have solved the question that they wanted you to find x. So again, you start with the rule. We know inverse variation is this rule. You use the information they gave you to plug in to solve for k. And you essentially put that back into the rule. And you can use it on anything now. Once you find that k value, that constant of variation, you have the rule for all possible x and y's. Okay, here's another one. Here we go. Y varies inversely with x. We know that means y equals k over x. So once you get into a rhythm, these all start to feel the same. We're going to plug in this information. So it'll help us find the k value. So y is 7 and x is -4. Here we go. To solve for k, we're just going to multiply both sides by -4 because that's the opposite of division, or the inverse of division. And we get k equals -28. There's the k value. Take it and put it back into the general form to give us our rule, our function rule. There we go. Now we can use this on any x and y. They happen to want to know, what is y when x is 5? So we're just going to plug in 5. And that looks pretty good. I'd probably just leave it like that because -28 and 5 do not have any common factors, so it cannot be reduced. If you're not sure, we could always check it in the calculator. -28 over 5. And then hit the fraction button, and it didn't do anything. See, there are no common factors to reduce that. All right, 2 more for us today, kind of just wrapping up everything we did. We've looked at the table type questions, and then we've also looked at these equation type questions. So here's the first one. We need to remember the 2 rules we're going to check. For direct variation, remember we're going to check to see if y over x is a constant value. Now, sometimes people get confused because you see this y over x and you think that's inverse. And I understand what you're saying, but remember, inverse, the general rule is k over x. This is y over x. The general rule is k over x, and k is y times x. Right? Remember, for direct, the general rule or function is y equals k times x, and x is y over, or okay, k is y over x. So you have your rule, and then you have your test. You have your rule and your test. So let's test direct. This is our test for direct. So we're going to take y divided by x. Negative 4 divided by 1 is negative 4. Negative 8 divided by 2 is negative 4. Negative 12 divided by 3. So, oh, my apologies. I really hope you don't have headphones in right now. That was probably very loud. Sorry about that. I couldn't get to the pause button in time. If we were live, we could all have a great laugh. All right, negative 16 divided by 4 is negative 4. So sure enough, these all have a constant change of negative 4. So it is direct variation, and the k value is negative 4. So our general form, general is y equals k times x, negative 4 times x. If you want to, we can just confirm it's not inverse for fun. Why not? The inverse rule is k equals y times x. So we're going to multiply them. 1 times negative 4 is negative 4. 2 times negative 8 is negative 16. See, they're already different. 3 times 12 is negative 36. And yeah, so this is totally not inverse. All right, let's do the last one. Y varies directly with x. So there's that sentence. We know it's going to be the general form of direct, which is y equals k times x. Now let's plug in what they gave us. Y is 15. X is negative 18. And solve for k. K equals, we're going to divide by both sides, right? 15 over negative 18. Now, I happen to realize, and you guys probably do too, that these numbers do have a common factor, something that will divide into them evenly. And it happens to be 3, right? So 15 divided by 3 is 5. And negative 18 divided by 3 is negative 6. So we're just reducing the fraction. We can also do this in the calculator. So 15, whoops, 15 divided by negative 18, and hit your fraction button, and there it is, negative 5 over 6. It reduced it for us. So that's our k value. Plug it back into your general form. You get y equals negative 5 over 6x. Now we have a general rule that we can use for any x and y values. They want us to do it when x is 1.6. All right. So y equals negative 5/6 times 1.6. What is y? I'm going to go to the calculator. Negative 5/6 times 1.6. And let's see if we can give us a fraction. Negative 4/3. There we go. There's the answer. So we've seen two types of variation today. Direct, which always goes through the origin. Inverse, which never goes through the origin. And then we've looked at the two different general forms and the two different k value tests, if you will. So I will see you guys soon. Coming up on Tuesday, we have our live class together. Wednesday, there are some sessions with Miss Jadala like usual, and you guys will be getting some email invitations for some benchmark review small group sessions coming up this week as well. So keep an eye out for that. And as always, just let me know if you guys have any questions at all. I'll see you on Tuesday. Bye.